In this video, we are going to practice graphing polynomial functions. All right, so here we have a polynomial function, negative 2 times x minus 1 squared times x squared minus 16. And we are going to follow these steps in order to graph the function. So step 1, we want to find the end behavior of the graph. Now, what we actually want to do in order to do this is find what would be the leading term of this polynomial if it was expressed in standard form. Here's the way I do that. There are 3 factors here. And so I'm going to take negative 2 from the first one. I'm going to multiply that by x squared in this case. And I'm going to multiply all that by x squared. So I take the leading term of each factor. And if there's an exponent on the outside of the parentheses, I will apply that to that leading term, and then I multiply all of them. So let me show you what that looks like. So my leading term of f of x will be equal to, I do negative 2 times x squared times x squared. All right, and that's pretty much it. And that gives me negative 2x to the 4th. I know that is my leading term. Now, the reason I do that is because I'm trying to find the end behavior of our function. So first, I just want to see, is it a positive or a negative leading term? This one is negative. Then I look at the exponent, and this is even. What this tells me is that the end function will be, the end behavior of this function will be the same as the end behavior of negative x squared, which means that it will go to negative infinity on the left and negative infinity on the right. Now, earlier in my class, I made, I guess that's in the other, we'll skip that for now. All right. So we have our end behavior of our function. We know that on the left and the right, it goes to negative infinity. Next, and I am just going to find the x-intercept next, step 2. And the way we find the x-intercept, or the y-intercept, I should say, is we are going to find f of 0. So the y-intercept will be equal to f of 0, which will be equal to negative 2, 0 minus 1 squared, 0 squared minus 16. And so I just plug in for 0. I end up with negative 2 times negative 1 squared times negative 16, which ends up being, this will be negative 2 times 1 times negative 16, so that's going to be positive 32. So my y-intercept is going to be 0, 32. All right, step 3, I am going to find my zeros and their multiplicity. This will basically tell me what the x-intercepts are and whether or not the graph touches or crosses at those x-intercepts. Now, there's a small issue here, which is that this is not fully factored. But we'll deal with that in just a second. All right. First, 0, since we have x minus 1 as one of our factors, that means we have a 0. And notice that it has an exponent of 2 on that factor, we know that one of our zeros will be positive 1 with multiplicity 2. And note that since that's an even number, since the multiplicity is even, it touches, the graph will touch at the point 1, 0, which is the x-intercept at 1. Now, x squared minus 16, you can't just say that that means that the 0 is positive 16 because we have an x squared here. So we'll have to do this more the long way, which is like this. I'm going to have to set x squared minus 16 equal to 0 and then solve for x. So this will end up being x squared equals positive 16. I add 16 to both sides, and then I take my square root. Make sure whenever you take the square root of both sides of an equation, you add a plus or minus. And in this case, the square root of 16 is actually a whole number. So we have plus or minus 4. Now, since we have these two zeros here, we can actually use these to factor out this equation more thoroughly. So I can replace x squared minus 16 with x plus 4 and x minus 4. And if you know the rule about the difference of squares, you could have done that immediately. You would not needed to solve for x. But in case you aren't super familiar with that rule, you can always just solve for x, and then if you get two real numbers, you can express both. You can replace, in this case, x squared minus 16 with the two factors x plus 4 and x minus 4. All right, so now we have two more zeros, which are negative 4 of multiplicity 1. And again, that really comes from this factor. And again, since it is an odd multiplicity, it's going to cross at negative 4, comma 0. And then looking at the last factor, we have x minus 4, which means that 4 is a 0 with multiplicity 1. And again, it'll cross at 4, 0. And I know it crosses because the multiplicity is odd. Step 4 says to find the maximum number of turning points in the graph. Looking again at my leading term of f of x from part 1, I know that my degree of f of x will be the degree of the leading term, which is 4, which means that the max number of turning points will be equal to 4 minus 1, which is 3. The maximum number of turning points of the graph of a polynomial is always one less than the degree. And at this point, we can at least sketch a graph, putting all of this information together. So I'm going to draw a quick XY axis. I guess the only problem is that 32, my y-intercept is going to be really way high in the sky. So what I'm going to do is I'm just going to go up by 4s on my x-axis. Okay, and so I'll start by, when graphing, here's my suggestion. Start by putting all the points where they belong. So here's my y-intercept at 0, 32. And then I'm going to do all of my zeros. which will happen. And for my x-intercept, I'm going to keep just 1, 2, 3, 4, 5. So I'm going to keep the normal scale going up by 1 here. So I have a 0 at 1, I have a 0 at 4, and I have a 0 at -4. All right. So now what I'm going to do is I'm going to start drawing it. I always have to decide, am I going to start from the top when I graph, or am I going to start from the bottom? This is when I look at my end behavior. So I know that I'm starting from -infinity going left to right. So I'm going to put my graph, and I'm just going to sketch this. It's not going to be perfect for right now. But I'm starting from -infinity. And you know what? I think it'll probably be more like this and then come down. And notice that it crossed at -4 so far. Now when I get to 1, it's going to touch and turn around. So let's do that part. It'll look something like this and turn around. When I get to the next point, the next x-intercept, which is 4, it's going to cross. So this will go up and then down. And notice that I'm going to -infinity on both sides. Now this is just a sketch of the graph, but it's a good place to start. And if you want to get more specific points to make your point more accurate, we can definitely do that. But my suggestion would be to use your graphing calculator or use Desmos. So we're going to go to Desmos. And we're going to put in the graph. All right. And again, I have to bring this down. Well, let's just check our work first before we see the whole thing. We'll check all of our x-intercepts. Those are all correct. If I'm not mistaken, we had -4, 1, and 4. That's good. And our y-intercept is correct. Now our general graph is about the right shape, but it goes way higher. It goes all the way up to almost 240 all the way at the top. So I'm not going to redraw this, but we'd have to go way up into the sky in order to graph this correctly. Who knows where it would be? Way up there. Even that wouldn't be far enough. And then how far would this next hump be? That would go to 56. So that next hump would still be more like that. However, I think the real point of these exercises is not to get the perfect graph, but to learn how to sketch a graph that looks decent, and this one looks decent. The other thing I'll want to double check, it crosses at -4, it crosses at 4, it touches at 1. I think that was a decent sketch of the graph. And again, if this was if these numbers were smaller, I would fix this graph and try to make it look perfect. But since there are such large numbers, I'd have to start all over at the beginning, and it's not really worth it, in my opinion. I think I'm happy with this sketch that I have. All right, let's do another problem using the same steps. But we're going to do number 22. All right. So let's do step 1. And again, what we really want to start with is we want to find the lead term of f of x. And the way I do this is, again, I take the lead term of every factor separately. So I'm going to highlight all the lead terms in all three factors. And in this case, there aren't really any exponents on the parentheses, but if there were, I would raise each one of these lead terms to that exponent. But I don't need to worry about that for here. So I know that this will be equal to x squared times x, which is x to the fifth. What does this tell me about my end behavior? Well, again, this is positive, and this is odd. That means that my graph is going to have the same end behavior as f of x to the f of x equals x to the third. So it looks something like this. It goes to negative infinity on the left, positive infinity on the right. And we are done with our end behavior. Step 2, we're going to find the y-intercept. So again, the way we do that is the y-intercept will always be equal to f of 0. So this is going to be equal to 0 squared times 0 squared plus 1 times 0 plus 4. This ends up being 0 times 1 times 4, which is just 0. So we have a y-intercept of 0. All right, next we are going to find the x-intercepts, also known as the zeros, and we're going to find the multiplicity of those zeros. All right. Since we have x squared equal to 0, the first two are not quite in the, if it's in a form that looks like this, it's very easy to find the 0. In fact, let's just find that 0 first. That 0 is going to be negative 4, and it has a multiplicity of 1. So that's odd, which means that it will cross at, my graph of this function will cross at negative 4, 0. For the other ones, you have to be a little bit more careful. They are not monomials where the degree of degree 1, in both they are of degree 2. So we want to solve equations here. So we want x squared equal to 0. That one actually you can tell right away. The only time that x squared is equal to 0 is if x is equal to 0. And you could take the square root of 0. You'd get plus or minus 0, but positive 0 is the same as negative 0. So we have another 0 at 0. The multiplicity, however, is actually equal to 2 because of that exponent in this case, right? Because it's x raised to the second power. Another way we can think of x squared is this is x minus 0 squared. And that makes it more obvious. Yes, that means that 0 is a 0, and it is of multiplicity 2. Since the multiplicity is even, it touches at 0, 0. All right, last we have to solve for the middle factor. I subtract 1 on both sides, and you get x squared equals negative 1. Take the square root of both sides, and you get plus or minus the square root of negative 1, which in other words, this is x is equal to plus or minus I. This is not a real 0, which means that we will not have an x-intercept at these zeros, right? If you ever end up with a zero that is not a real number, that means you won't have an x-intercept there. So we have found two of our zeros. All right, step 4 is just to figure out the maximum amount of turning points. Since the degree of f of x is equal to 5, the max number of turning points is one less than that, which is 4. And again, the way we get the degree is by looking at the lead term. Look at the exponent. That will be the degree of this function. All right, we have enough information to graph this one now. So let's put it all together. All right. We just have two zeros. We have a 0 at 0, and we have a 0 at -4. All right. Our y-intercept is the same as our x-intercept, so that's already been graphed. And so now we're just going to look at our end behavior, and I know that I start in the lower left, and I'm going to cross at -4. So let's start with that. Something like this. Next, my graph is going to touch at 0. So it comes back down, and then I think it's just going to keep going up. Now it's possible, maybe, that it goes like this because we could have as many as 4 turning points. So here we have 1, 2, 3, 4. But we'll start with the simplest, and then maybe after we graph it, we will adjust the graph depending on what it looks like. All right, let's go to Desmos. And let's double check our work. X squared. Oh, let me reset this. So it's x squared x squared plus 1. And then I think it's x plus 4, if I'm not mistaken. Okay. And to be honest, our graph looks pretty good. Again, unfortunately, it goes to this really big maximum all the way up at about 92. So this part is way too low. But maybe here's what we can do. Here's a cheat sheet. I didn't graph this. I didn't put anything on the y-axis, so I'm just going to say that's 92. It's kind of cheating, but it's not so bad. And I have a decent looking graph that matches what I have. Okay, so that's more or less what that looks like. You could argue that it's a little bit, I mean, you could definitely add a couple more points so it looks a little bit better. But again, I think the whole point of these exercises is not to get a perfect graph, because if you want a perfect graph, you can just use Desmos or use a graphing calculator. I think it's just a nice way of exploring all of the facts that you can know about a polynomial function when you have it in factored form, and just practicing sketching the graph, not getting a perfect graph, which is what we were able to do without using a graphing calculator. All right, so I hope that was helpful. We'll do 2 more examples just like this in the next video, but I think this video is long enough. So that will be it for this video. Hope it was helpful, and we will see you in the next video.